Squares, cubes, and roots. If I ask you to square a number, such as, let's say I say, what is 7 squared? You all know that means what 7 times 7, which is 49. What if I ask you to square negative 3? Be careful with that. If I say square negative 3, that's not right. Whatever I'm squaring, if it has a negative, is going to need some brackets to tie it all together. Negative 3 squared means take negative 3 times negative 3, which of course is 9. If, however, you see this, be careful. The difference here, there's no brackets. This means subtract or take the negative of 4 times 4. So you're going to have minus 16. This you're going to see will happen in an expression where you'll have something in front, 25, take away 4 squared, and so on. Be careful, if there's no brackets, that negative is not tied to the 4. But you know this. This is good old squaring, which you have done in the past. You probably also know what a cube is. If I ask you to cube 7 instead of squaring it, then instead of 7 times 7 is 49, we're going to go 7 times 7 times 7. On your calculator, you probably have a button that looks like this, the roof of a house. That means 7 to the 3. You might have a button that looks like this, or a button that looks like that. Get to know your calculator. All of those will find 7 to the power of 3 for you, which is 343. Likewise, if I have a negative, negative 3 cubed, it means take 3 of them this time. Again, notice I'm using brackets to show my multiplication and to keep my negatives tied together. Will be negative 27. If I go negative 3 with no brackets cubed, I also get negative 27 because all I'm cubing is that 3. Notice the difference there between when I squared and when I cubed. When I squared without the brackets, my answer ended up negative because that negative sat in front all the way along. Whereas when I cube, it ends up negative because it's not a part of these brackets, and we just get the negative 27. Okay, that's the easy part. Now on to the new stuff. What happens when we talk about roots? You've all heard of a square root. Taking the square root is the opposite of squaring. In math, there are always, everything you can do has an opposite. Adding the opposite is subtracting, multiplying is dividing. Square root and squaring are opposites. So when we said that 7 squared was 49, 49 is called a perfect square. And if I ask you what is the square root of 49, you know that it's 7. Why? Here's why. When we talk about the square root of 49, we know that we're really talking about the square root of 7 squared. We already know that from when we talked about the squares. When I have a square root, which is this sign, that little notch is important, by the way. You know this is dividing. This is square root. Make sure you do that right. The square root sign cancels out the squaring because they're opposite. They undo one another. So the square root of 49 is 7. What's the square root of 121? Since 121 is 11 squared, the root of 121 is the same as the root of 11 squared. This cancels this, and I'm left with 11. What about this one? If I give you that sign, now there's a number in there. On the previous, there was no little number in there. We know if there's nothing in there, it's square root. If there's a 3 in the little notch, this means find the cube root. To find the cube root, we need to think about how can I rewrite what's underneath here as a power of 3, something cubed. 27, we know, how many 3's can we get in one question, is the cube root of 3 to the 3. The cube root cancels the cubed. So the cube root of 27 is 3. What's the cube root of 125? 125 is 5 cubed. The cube root cancels the cubed, and the square root of 125 is the same as 5. How do you know this? How do you figure out what 125 is as something cubed? Well, most of the time, if you're talking about a number, even up to 125, you're going to be expected to have some basic number facts in your head. However, if you don't, and you need to figure it out, let's say I ask you this one. Let's go with a pen you can see. What if I ask you what's the cube root of 3,375? That is not something most of us have in our head to change to the cube root of something cubed. So how do we do that? If you think back to the first couple of videos in this section, we talked about writing things as prime factorization. In other words, rewriting our number as a bunch of numbers that are prime multiplied together. And to do that, we either wrote a factor tree where you split the lines and worked your way down, or went this way and said, what's the smallest prime number that goes into 3375? And that would be 5. 5 goes into there how many times? Use a calculator if you have to. You'll get 675. Now, how do I know 5 goes into there? Remember, if a number ends in 5, it's divisible by 5. How many 5s in 675? 135 of them. There's another 5. And I'm going to keep going. Oh, 5 doesn't go anymore. We're going to have to switch to 3. And what you're going to look for are things that there are 3 of. Because we are looking for a cube root, we want factors that appear in groups of 3. Why? Because this is going to give us the ability to change this 3,375 into 5 cubed, since there's 3 of them, times 3 cubed. This means that the cube root of 3,375 is the same as the cube root of 5 cubed times the cube root of 3 cubed. Now, just like we were doing with the previous examples, cube root cancels cubed. And we are left with 5 times 3, which is 15. What do we know? The cube root of 3375 is 15. What if you wanted to check this? Please don't just start checking and carrying on in your work. It's very confusing. Right. Check with a colon and say, here's where I'm going to do my check. How do you check it? If the cube root of 3375 is 15, then you need to check what in the world is 15 cubed. You grab your calculator, punch in 15 cubed, and you'll get 3375. You know you're right. The cube root of 3375 is 15, since 15 cubed is 3375.